acid rain. I am not going to test you on acid rain, but I want to talk about it because it relates to what we've been learning about, and it should be of concern to all people living on the planet. So fossil fuels, like gasoline, oil, coal, that we burn contain small amounts of sulfur impurities, right? Coal is especially bad for this. It has more sulfur than other fossil fuels. So when you burn coal or anything with sulfur in it, it's going to form SO2 during that combustion. And also during combustion, nitrogen from the air will react with oxygen and form NO2. So what happens is that SO2 that's formed in the combustion can react with oxygen and with water that's in the atmosphere and form sulfuric acid. Is sulfuric acid in the air a good thing? Doesn't sound like a good idea, does it? NO2 can do the same thing. It reacts with oxygen and water, which are both naturally present in the air, and form nitric acid. So burning fossil fuels can form sulfuric acid and nitric acid. Not directly, but the products of the combustion react with things in the air and form these. So acid rain is when these acids in the air combine with rain and come down, right? So now the rainwater is going to be acidic. It's really interesting how the problem of acid rain is different depending on different parts of the country. So it's the biggest problem in the Northeast, in New England, because natural air currents bring the SO2 and NO2 that are formed by coal combustion in the Midwest, and they blow it to the east. So they're getting more of this, the acid, right? Rain is naturally somewhat acidic because carbon dioxide dissolves in water and forms carbonic acid. But carbonic acid is a relatively weak acid. Sulfuric acid and nitric acid are strong acids, right? So carbonic acid is relatively weak. So if you have rain that's saturated with CO2, it's going to have a pH of 5.6, which is acidic, but not very, right? When the nitric acid and sulfuric acid mix with the rain, then the pH is going to be lower. It can go below 4.3. Like 5.6, 4.3. This is a logarithmic scale, like earthquake scale, right? So this is 20 times higher in concentration of hydronium ion than that one. That is a big deal, right? So what happens when acid rain comes down? Well, acids react with a lot of different things. Acids can dissolve a lot of metals. Not all of them, but a lot of them. They also react with carbonates. So metals, there's metals in bridges, railroad ties, your car. So we get rust and things, degrading. Marble, limestone, cement, these all have a significant amount of carbonate in them. And so in this illustration, we've got these two gargoyles on it's got to be a very old building. This one looks like it was a little more protected from the rain than that one. This one has just been eroded and has lost most of its detail just from years and years and years of rain. So that's not good. The acid rain is also going to accumulate in lakes and rivers. Do fish and other aquatic life like their water pH changed? No, they don't. They don't. It's not much of a problem in the Midwest because the soil there has a lot of limestone in it, which neutralizes the acid and keeps the lakes from becoming acidified. But in the Northeast, there's not very much limestone, and so the Northeast lakes have more of a problem with this. And then trees can also be affected. And you might think, well, oh, those poor trees lost all their leaves because the acid came down and destroyed their leaves. No, that's not what's hurting them. It's the acid gets into the soil and removes nutrients from the soil, and that's what stresses out the trees and causes them to die. So back in 1990, which seems like ancient history to you guys. Let's see, I got married. They made some amendments to the Clean Air Act, and so legislation forced utilities to lower their SO2 emissions. It wasn't you have to stop right now because that's not possible, but it was a staged thing. It's like, okay, you have to cut it this much by now and this much by then. And so if we look at the concentration of SO2 in the air from 1990 to 2016, we see a significant decrease, right? It went from maybe like 130 parts per billion down to, looks like maybe 20 parts per billion. That's a big decrease, right? Does that solve the problem? No, but it makes it much, much better, right? And so now the acidity of rain has gone down from where it had been, and a lot of the lakes and forests are starting to recover from that. The end.